Good morning, class. Welcome to the online classes for class 10 physics. In the previous classes, we were learning about the chapter light. In that, we have learned what the light is and what are the phenomenons. In that phenomenon, we have read about what is reflection, right? But in this class, we will be learning about the mirrors and what is refraction. So just let's start the class. Before going to the next topic, just recall what we have learned, that what the light is, right? Light is a form of energy which enables us to see the object. So for a dark room, we have seen example that whenever we switch on the light, or it will be morning, then the light rays from the sun or from the tube light and all, when it falls on an object, we are able to see that object. Otherwise, we are not able to see that. So that is, the light is a form of energy that enables us to see the object. And the next thing, we have seen the properties of light, that light has a dual nature, that it travels in the form of wave also and travels in the form of particle also. It tends to travel in the straight line, and it propagates, does not need a medium, so it does not propagate in a medium. So it is taken in the form of the electromagnetic waves, and this visible light that is in the range between the 4000 Armstrong to 7000 Armstrong. And we have seen that the light is always travel in the form of a ray that goes into the straight line and moves into a medium, but it does not even need a medium to travel. So that were the properties of light. And for the next, we have seen that there are the two phenomena for the light. One is reflection and the other is refraction. For reflection, we have seen that whenever the bouncing back of a light or getting back of a light from the surface, that whenever the light ray falls on a surface, strikes at a point and come back in the direction, then it is said to be the reflection, right? And that reflection, we have seen that the light ray which falls on the surface is said to be the incident ray, and the light ray which is coming back is said to be the reflected ray. And for getting what is the angle between this incident ray and the reflected ray, we have to draw an imaginary line which is said to be the normal ray, and throughout these normal, we used to find out the angle that is between the reflected ray and the normal, and the incident ray and the normal, and the angle between this is said to be the angle of incidence, and the angle between the reflected and the normal is said to be the angle of reflection, right? And we have seen the laws of reflection also. There are the two laws of reflection, that incident ray, normal ray and the reflected ray should fall on the same plane. And the second one was that the angle of incidence should be equals to the angle of reflection. Similarly, we will saying about what the refraction is in this session. So before that, we have read that the reflection takes place in the plane mirror, that is, it is shown with the help of a straight line because it is a plane, so it is shown with the help of a plane mirror. But now in this class, we will be seeing about what the spherical mirror is. So by the name itself, we can say that the mirror should be in the shape of sphere. So we are saying to see about what the spherical mirror is. Now we have seen that whenever the light ray falls on the plane mirror, that is shown with the help of the straight line. We have seen this kind of diagram in the figure, and the oblique lines are shown that is not a reflecting part, and this is a reflecting surface. Whenever the light ray falls on the surface, it return back. So we can say that any light ray falling on the object come back or reflected back with the parallel beam of light. But when we talk about the spherical mirror, it will be not like this. So we can say that it is a part of a sphere or a hollow sphere of glass. So when we will cut it out, then it will get a mirror which is said to be a spherical mirror. So we can see now what the plane mirror was, that whenever a light ray falls on the plane mirror, it just strikes the surface, and from that point the parallel rays come out. So beam of the parallel light rays can be fall on the plane mirror, and it reflects also a plane beam of light. But when we talk about the spherical mirror, now we can say that the parallel beam of light rays, instead of that, now the light rays will start converging, that is, they will be coming or can meet at any point, or they will be diverging, that will they will moving away from the points. So we can say that light rays will not be parallel. So to define what the spherical mirror is, the spherical mirror is that mirror whose reflecting surface, that is the part which is reflected, will be taken from the hollow sphere. So it is just a part of the hollow sphere, and so therefore it is named as a spherical mirror. Okay. There will be the two spherical mirrors which you have to learn in this chapter. One is concave and the other is convex mirror. So you can see the figure also that this is the concave mirror and this is the convex mirror. But for that we have to draw the oblique lines, that which is the reflecting surface. If this is the reflecting surface, this oblique line shows the non-reflecting surface. Okay, so here these bent in surface is the reflecting, and here this bulged out surface is the non-reflecting, that is the reflecting surface. Okay, so what we can say, that mirror, the spherical mirror whose bent in surface is the reflecting surface, is said to be the concave mirror, right? And the surface whose bulged out surface is the reflecting one is said to be the convex mirror. Okay, so for this we can take an example of a steel spoon, because in that spoon we can see in both that concave as well as the convex mirror. Okay, so the inner shining surface of the steel spoon will be the concave and the outer surface will be the convex. Okay, so we'll see some more things and some more parameters about the spherical mirror. So by showing this oblique lines, you can tell what the mirror is, because which is the non-reflecting surface and which is the reflecting surface, we can identify the mirror. Now to imagine what the parameters are present inside the mirror, you can say that if you are having a mirror, okay, this with a mirror whose reflecting surface is the bulged out surface. Let it be now that it be a bulged out surface, not concave and convex I am explaining. If this is the non-reflecting surface, okay, this is the non-reflecting surface. Now if we will imagine that this is the part of the sphere, right? It is a part of sphere. So what we can say, since it is a part of sphere, as sphere also have the center, similarly this spherical mirror also will have a center. And now if I am drawing an axis that passes through the center, okay, let this line be, I know my diagram is very poor, but just try to understand. Let this be the ray passing through the center of the sphere be the line, that is axis, and this axis which is passing through the center is said to be the principal axis. So we just have to imagine that it is a part of a sphere, so that we can tell what the spherical mirror center is, what is the focus, and what this principal axis is. So if this is the mirror, then we are just imagining that is a part of the sphere. So this is the line which is passing through the center of the mirror is said, if the center is shown with the C, then this XY axis will be said as the principal axis. The line or the straight line which is passing through the center is said to be the principal axis, and this imaginary center of the sphere is said to be the center of the curvature. The spherical mirror's center will also be same as that of the sphere. So this is a center of curvature which is shown with the letter C, and this XY is a principal axis. Okay, so we know that this is the reflecting surface, right? This is the reflecting part of the mirror. So the part of the mirror which is going to be reflected is said to be the aperture. This is aperture. So we can also say this aperture as the size or the height, the actual part of the mirror which is going to reflect the surface, right? Reflecting surface of that mirror, or the part which is going to reflect the light. So we can say it as a size, or we can say that the height of the mirror which is going to reflect. So these are the parameters through which we can imagine it is a part of a sphere, and we can tell. Okay, so we'll be saying some more parameters by saying what this beam do in the concave and the convex mirror. So now I have told you that this is a concave mirror whose bulged out surface is non-reflecting and the bent in surface is the reflecting surface. Now if we draw a principal axis which is passing through the center, this be the C and this XY be the principal axis. Now the rule what it says, that if the parallel light rays falls on the surface of the concave mirror, then these light rays converge themselves. And what this converge means they actually meet at some point, that is in front or behind the mirror, and these point where this reflected light rays meet are said to be the focus. So it is denoted by the letter F, and it is focus of the mirror. So we can say focus of a concave mirror is the point on which the light rays after reflection converge, or we can say after reflection it meets on the point which is F. It is actual meeting, because in the convex you will read that it does not actual meet, but we have to imagine that by extending it somewhere it is going to meet. So the point where this light reflected parallel beams reflect or meet is said to be focus. Okay, and now if we are having a center of the sphere, then r, that is radius, will also be there. And what we can say that radius is the distance from the center to any of the point on the surface of the mirror. So if this is the mirror and this is the C, then the distance between the any point and that center of the sphere is said to be the radius, that is r, right? And now we have seen that in the concave mirror, when this light rays falls on the point and meet at the point, this is said to be the focus, that is F. But what this focal length is? So we can say like if we are having this converged light rays in front of the center like this, if this is the principal axis, let this be the parallel light rays and this be converging at the point, this be focus and this be the center of the curvature, then the distance between these focus and the part of the mirror is said to be the focal length, and it is given by the letter small f, where small f is the focal length. But we have already told that the distance between the center and the surface of the mirror is said to be the radius. So what we can relate the radius and the focal length to be? That focal length is half of the radius, or we can say that radius is the double of the focal length. So what is focal length? Focal length is the distance of the pole of the mirror to that of the principal focus, or that focus, that is capital F. So my diagram is already poor, so you can see this in the textbook figure also, that what the center of the curvature and how it is shown, convergence and light rays falls on the meet on the focus. This figure is better to understand, because the parallel light rays are entering on the surface and strikes to the surface of the concave mirror, that is the bent in surface, and after striking the surface they come back and meet at a point. That point is said to be focus, that is principal focus. It is denoted by the letter capital F, and C is the imaginary center of that sphere from where this mirror is taken as a part. So we can say that the light rays converge to a point or meet at a point, and the distance between these point and the pole is said to be the focal length, and pole is the center of the mirror, okay, through which this principal axis moves. This is center of the mirror is pole, that is given by the letter P. It is not principal axis, but it is pole. So distance between the pole and the focus is said to be small f, focal length. Okay. So this is what the concave mirror tells us about. Now when we talk about a convex mirror, remember this, that in the convex mirror the bent in or the inside surface is non-reflecting, but the outer surface is a reflecting surface. Now if you have this, as it is uneven, so it will try to move this light rays outward direction, so it will move somewhere out. Okay, so all these light rays are going outward direction, so we can say they are diverging from the surface. Now we have told that focus is that point where these reflected light rays should meet, but whether the light ray is actually meeting here, no. So we just have to extend these light rays on the backwards, so we got a point where this light rays meet. So focus of these convex mirror has to be imagined, or we have to extend the light rays, then we will get the focus. So focus of the convex mirror is behind the mirror. Okay, so it is back of the mirror, so we can say that the image will be formed as a virtual image. So if we are getting the image by the actual meeting, so it is said to be the real image. And if the object is formed and the image is formed due to the extension of that light rays, is said to be the virtual image. We will be saying more about this virtual and the real images, but now we are seeing about the concave and the convex. Then we can say that it just diverges the light. So this mirror are also said to be the diverging mirror. So what this convex mirror is said to be, it is a diverging mirror, and concave mirror is said to be the converging mirror. One is converging and the other one is diverging mirror. So which is converging? It is concave mirror, and which is the diverging one? It is the convex mirror. Okay. So in the next session we will be seeing about the rules of this concave and the convex mirror, how this light rays falls on the surface and how does it gives the image, and what is the type of the image that is formed by the concave and the convex mirror. So here we will be seeing the other topic, that is other phenomenon of the light, because in the last time we have seen that reflection phenomenon, that in the reflection whenever the light rays falls on the surface, then it just strikes the surface and reflect back in the direction, but it happens in the same medium. And to find it, we used to draw a normal light ray, and this ray which falls on the surface is said to be the incident ray, and the light ray which bounces back from the surface is said to be the reflected ray, and these imaginary line, that is M and B, the normal ray. So this point is said to be the point of incident, the point at which the light ray falls and the get reflected back. And we have learned the law of reflection was angle of incidence should be equals to the angle of reflection, and the light ray, normal ray and the incident ray should also fall on the same plane. But here we have said the word that it is the same medium. So when this light ray phenomenon does happen in the different medium, then it is said to be the refraction. Now let us consider if any object is there that of another medium, then whenever the light ray comes from the other medium and falls, enters into the other medium and again come back to the other medium, then it is said to be the refraction. So we can say that whenever the light ray falls from the rarer to denser or denser to rarer. Now what this rarer and denser medium is? Rarer means the medium which have no less obstacles for the light, that the particles are at a far distance, so the obstacles is less. And if we say the obstacles are more, that is the objects particles are closer to each other and it's said to be dense. So for the dense part, the light ray could not flow easily or pass easily. But if we talk about the rarer medium, it can flow easily. And for the rarest medium, it is air. So air is the best medium to travel for a light. Okay. So whenever the light ray travels from rarer to denser medium, if I imagine a normal ray, then the light ray which is refracted, it used to be towards the normal, then it bent towards the normal. And if it moves from the denser to rarer medium, that is, it is coming back from the denser and moves to the rarer medium, then the light ray will pass away from the normal, then it will move away from the normal. So we can say that this light ray means mostly it bends. So this bending of light ray is said to be the refraction. So refraction, we can say that it is passes from one medium to other medium, and this light ray bending when it goes from one medium to other. So this medium dispersion or this medium change in the rarer and the denser and the bending of light, this phenomenon together is said to be the refraction of light. So how this refraction done? If we took a glass slab, because it is a glass slab, so it will be the denser medium, and now if we are able to try to follow a light surface from a source, then it will be coming from a rarer medium because it is falling from the air. This be the air, this light ray is falling on the surface, so it is a point of incident and this is the incident ray. When it falls, let us consider this is be the normal, this is M, N. Then the light ray will come to the denser medium. I already told you that when the light rays enters into the denser medium, the obstacles are more, so it will be moving towards the normal, that is, it is moving towards the normal. Okay, so on moving towards the normal, okay, so there is a bend, right? And again here, after getting from the denser to rarer, because light ray have to come out, so after coming out from denser to rarer, it will move away from the normal. If this is the normal, then it is moving away from the normal. So we can say this light ray is bending. This is the incident ray, this is the refracted ray, and this is the emergent ray. We will see it. So these bending of light ray is said to be the refraction. Now we can say that the bending of the light ray is said to be the refraction. then what this refraction tells us about, here the two figures are shown for you, that whenever the light ray comes from the rarer to denser, then it moves towards the normal, and when it moves from denser to rarer medium, then it moves away from the normal. So this bending of light ray was refraction. Now what this light ray tells us about, then the light ray which falls on the surface is said to be the incident ray. Okay, this light ray coming to the surface is the incident ray. Now the light ray which is coming towards the normal will be the refracted ray, and when this light ray again come back from the denser to rarer medium, then it is said to be the emergent ray, because it is emerging from the surface, so it is said to be the emergent ray. So there are the three rays which we can see, which are, one is incident ray. Here you can see more clear that it is the incident ray which falls on the surface, and from there it is moving towards the normal, that it is moving from rarer to denser, so it will move, the light ray will move towards the normal. And this ray coming from the glass ray is said to be the refracted, because it is moving to one medium to other, so it is said to be the refracted ray. Again this refracted ray have to come out from the surface, so this ray which is coming out from surface is said to be the emergent ray, because it is emerging from the surface. Okay, so this light ray bending in the surface while moving from rarer to denser or to denser to rarer, so this light ray is said to be the refraction. And similar to this we have to do the practical also with a rectangular glass slab. There you will understand more easy that the light rays bends, and there you can see the more practically that how this light ray bends. Okay, so what the refraction was, whenever the light ray passes from one medium to the other medium, and this bends towards or away from the normal, then this bending of the light ray is said to be the refraction. Now we have already learned what the law of reflection was. Similarly we are having the law of refraction also. So here also there are two laws for the refraction. One is that which is similar to that of the reflection, that the incident ray, the normal ray and the reflected ray should all lie on the same plane. Here the emergent ray, incident ray and the refracted ray should lie on the same plane. That is the normal, refracted and the incident ray should lie on the same plane. And what the second law tells us, that is the ratio of the sine theta. You know about the sine? So the sine of angle of incidence, instead of theta we are taking as incident. So what measurement of the value of theta for the incident ray in the ratio of the sine of the angle of refraction, then the ratio of this sine of angle of incidence and the sine of angle of refraction is constant. It should always be a constant. This is the second law of the refraction, and this law is said to be the Snell's, because it was given by Snell experimentally. So this law is said to be the Snell's law of refraction. So this law was sine I upon sine R equals to constant. Okay, so these were the two laws for the refraction, and the value which was given by these ratios, that is sine I upon sine R, together it is given as mu, that is refractive index. For the topic which you are going to do in the practical also, you have to find the incident angle and the angle of refraction, and then you have to put this value of I and R in the sine. That is, if you get a 30 degree, then it will be sine 30 upon sine 30 if the angle of refraction and incidence is same, and if it's different, that is 30 and 60, then you have to take sine 30 upon sine 60. So you will get some value, that is 1 by root 3 if you want, and if you have to divide it, then it will be something like 1.67 something. So this will be the value for the refractive index. So what we can say, that the value coming out by the ratios of the sine of angle of incidence and the sine of angle of refraction, then the value is said to be the refractive index. It is given by mostly by the letter mu, and sometimes it uses n also. So it is given by refractive index. So these are the law of the refraction. So what we have learned in this here in this class, that what the phenomenon refraction is, reflection is, and what the concave and the convex mirror is. So in the next classes we will be seeing what the rules for the formation of the images in the concave and the convex, and what the mirror formula is, and for that we will be solving the numericals, and in the next class then we will be seeing the lens. Okay, for that we will be completing the chapter light, and after that we will be learning about the human eye and the colorful world. Okay, thank you class. So if you have any query regarding this chapter, you can ask me.